Yo, what is up, guys? Today we are talking about command of evidence data. It is Freddie Knows Ball here, back with the last video of the reading and writing part of the SAT Road to 1600 series. I'm super excited, and I've got some ball knowledge for you guys today. Matter of fact, let's just do it right now.
Ball knowledge.
That's right, guys. We don't need any more intro than that. The ball knowledge for today is to highlight the claim. I know I said it in the last video, but in the last video, that wasn't the ball knowledge. So while this question type is similar, since it is also command of evidence, it is similar to the last video we did, or the last question type. The only difference is on this one, you're going to see a lot of graphs, you're going to see different charts, and it's important to know how to read them and everything. But yeah, the ball knowledge for this is definitely to highlight the claim, because without the claim, it is really, really difficult to understand. And typically, they made it easier for command of evidence data actually to find the claim. Typically, it's at the end of the passage. So that's just a good tip to look out for. Keep an eye out for that. I also want to mention that the order you read the data tables or the charts in is pretty important as well. You want to start with the titles, and then you want to look at the rows, then the columns. The rows and columns aren't as important, but I would definitely start with the title just because it helps you understand what the graph is actually going to be about. And it is beneficial to read the rows after the title. Also, build your own solution. This is the last time you'll hear me say that, guys. I know, I've been saying it every video, but this is the last reading and writing question type. So this is the last time you have to hear me say, boss the question, please. All right. Obviously, it's not going to be perfect every time, especially because it's so open-ended with command of evidence data. But that's how it be sometimes. You gotta push through, and you gotta put in the reps. Don't forget that. Let's move on to our first question. This is a medium difficulty, as per usual with the first question. And it is about California condor populations. So let's go ahead and read the text. The California Condor Recovery Program is working to protect this large, rare American vulture from extinction. The program captured 27 wild condors in 1987 in order to protect and breed them. Captive birds have been reintroduced into the wild since 1992. Although the California condor is still a rare species, many biologists claim that the program can be reasonably successful. So there's the claim. The program can be reasonably successful. Wow. So there's the claim. The program has been reasonably successful. Now the question is, which choice best describes data that supports the claim? So we're trying to support the claim that the program has been successful. Well, let's look at the graph. We have the number of condors and the year. So typically, success would be seen through the increase of the populations through the years, or maintenance of the populations through the years, over the years. The number of captive California condors steadily decreased between 2014 and 2020. So a decrease would not actually prove that the program was successful, because we want condors to increase or maintain, obviously. So A is incorrect here. The numbers of California condors living both in captivity and in the wild decreased only slightly from 2019 to 2020. Why would we talk about the decrease? We have so much more that we can talk about, right? That's a really bad answer choice. It's not supporting, so I don't like it. The difference between the number of captive and wild California condors remained relatively steady between 2014 and 2017. I would like to see something that's talking about the entire time scale. I would more so like to see something talking about the increase of the wild condors, because that's kind of something that can show that the program's been successful. But yeah, C is... it's showing maintenance, so I'll keep it for now. The number of wild California condors increased overall from 2014 to 2020 and exceeded the number of those living in captivity. This is a much stronger answer, so I'm definitely picking B here, because it's talking about the increase, and it's talking about the entire time scale, and it says that it exceeded the number of those living in captivity, which is something that does support the biologist's claim. This question is talking about metal content of plants with and without K exposure, all right? Many plants lose their leaf color when exposed to K, an antibiotic produced by some soil microorganisms. Spelman, college biologist, and her colleagues hypothesized that the plant's response to K exposure involves altering their uptake of metals such as iron and zinc. The researchers grew two groups of seedlings of the plant AT, half of which were exposed to K, and half of which were a control group without exposure to it. and measured the plant's metal content 5 days after germination. So in this question, the claim is actually, the hypothesis that we're looking for is actually not at the end. It is closer to the beginning, and it is that plants' response to K exposure involves altering their uptake of metals, such as iron and zinc. So we have to see where in the graph is that supported, because the question is asking which choice supports the hypothesis. So we can clearly see that zinc and iron are greater without K, okay? So they have greater metal content, and they're hypothesizing that with K, the uptake of metals will change. And I believe that the graph shows this perfectly, so we just got to find an answer choice that matches that. Which choice best describes data in the graph that support the hypothesis? The control plants contained higher levels of zinc than iron, but plants exposed to K contained higher levels of iron than zinc. That's not proving the point. Both groups of plants contain more than 200 parts per million. That's also not proving the point. We have to talk about without K, the metals had a change in uptake, right? Had an altering of uptake. Zinc levels were around 300 parts per million in the control plants, but nearly 400 parts per million in the plants exposed to K. No. Well, that does talk about the zinc levels and how those were altered, but I would like to talk about the iron and the zinc. The plants exposed to K showed lower levels of iron and zinc than the control plants did. That's talking about iron and zinc, and that's what the hypothesis is also talking about. So that is a better answer. And yeah, so D is the correct answer here. This is the spider population count. To investigate the effect of lizard predation on spider populations, a student in a biology class placed spiders in 2 enclosures, one with lizards and one without, and tracked the number of spiders in the enclosures for 30 days. The student concluded that the reduction in the spider population count in the enclosure with lizards by day 30 was entirely attributable to the presence of lizards. So the student's conclusion is that less spiders with the lizards was correlated to how many lizards there were. So let's see, we're trying to weaken the student's conclusion. Let's see if we can do that. So if I'm trying to prove the fact that lizards did not have something to do with the spider population, I'm going to talk about how there is still a drastic decrease in spider population without the lizards. So let's see which answer choice best does that. The spider population count was the same in both enclosures on day 1. That's not really showing anything because it's day 1, most of the spiders are going to be there whether you like it or not. The spider population count also substantially declined by day 30 in the enclosure without lizards. That's exactly what I was looking for, right? You want to see that there's still a downward trend without the lizards, just as there is with the lizards. So that does weaken the student's conclusion. The largest decline in the enclosure with lizards occurred from day 1 to day 10. That doesn't really prove anything. The spider population count on day 30 was lower in the enclosure with lizards than in the enclosure without lizards. So yeah, but that's kind of supporting the conclusion. So D can't be right, and B is our correct answer here. Here's the final question. We're talking about Swahili speakers in 3 African countries. Swahili is estimated to be the first language of up to 15 million people worldwide. It's also an officially recognized language in Tanzania, Kenya, and the DRC, which means these countries use Swahili in government documents and proceedings. But even in countries where almost everyone speaks Swahili, for many it isn't their first language, but it is instead their second, third, or even fourth language. So in this one, you see that they underline something. That's pretty much, they already highlighted it for you, right? They made it easy for you. So the question wants us to use data from the table to support the underlying claim. We have to support the claim that Swahili wasn't most countries' first language. So according to the table, we see the approximate number of speakers and the estimated percent of population. So we have to say that even with the countries that speak Swahili, most of them didn't have it as their first language. So we see that the text says up to 15 million people had Swahili as their first language. In the graph, we see that 61 million people in Tanzania, estimated to be 100% of the population, speak Swahili. That's a drastically larger number than 15 million. So just from that alone, I'm saying there's our evidence. 61 million people speak Swahili in Tanzania, and it's estimated to be the first language of only 15 million of them. So I'm looking for something that supports that. Tanzania has approximately 61 million Swahili speakers, which is much more than the estimated total number of people worldwide for whom Swahili is their first language. Exactly. That's exactly right, because it has way more speakers than the amounts that had it as the first language. Tanzania is estimated to have at most 15 million Swahili speakers, while the country's total is approximately 61 million people. Well, that's just not true according to the table, because the table says Tanzania has 61 million Swahili speakers, not 15 million. Approximately 100% of the people who speak Swahili as their first language live in Kenya, which has a total population of approximately 55 million people. So their total population is approximately 55 million, and 100% of the people who speak Swahili is in Kenya, but not as their first language. So that doesn't support the underlined claim. Approximately 100% of Kenya's population speaks Swahili, while only about 25% of the DRC population speaks Swahili. That has nothing to do with the underlined claim. And so A is our correct answer here. That is all I have for you guys today. I hope you guys enjoyed. I hope this helped you guys out somewhat. Hopefully it changed some sort of perspective for you. These are some pretty difficult questions. I would say I struggled with this question type a fair bit when studying for the SAT. And it took a lot of practice, to be honest. But I think you guys can get the hang of it with enough practice. And if you have any questions, please leave them in the comments below. But besides that, that is all I have for you guys. I'm super excited to get started on the math section of this Road to 1600 series. I'm going to try to change up the editing style a little bit, try to make it easier for you guys to understand, and also just try to make sure that I get the ball knowledge out to you, and of course, Desmos is going to be pretty prevalent. So I will see you guys there. Peace.